All right, everyone, we have Bill Hahn here, who's our keynote speaker for today from Siemens, presenting model-based systems engineering approach. This is actually something Applied is really heavily invested in, so we're excited to show this for you. Thanks, Bill.
Yep, sounds good. All right, so I'm Bill Hahn. I'm a pre-sales director at Siemens. My team focused specifically around building a systems engineering digital thread. And if you haven't heard the terminology about digital threads, it's really about creating that connectivity of data throughout the entire life cycle, which may span many products, all of Siemens portfolio, as well as a lot of other products that we integrate with out there. So I'll start. I see if the keyboard works here. Start with just kind of doing a level set on systems engineering. We're having a conversation at lunch on what is systems engineering. A lot of people, when they hear systems engineering, they go straight to thinking about MBSE. So there's kind of a differentiation there. Systems engineering as a methodology has been around for a while before the tools kind of came up to support it. But what systems engineering really is just that process, that methodology for designing a system. So you're probably doing some level of systems engineering today if you make a product, right? There's no way to get around not having requirements and verifying those requirements and making sure engineering today product is validated. That's a systems engineering process. When we talk about MBSE or model-based systems engineering, it's specifically around applying model-based technologies, tools, and techniques to better understand that system. You can go through this entire systems engineering process on paper, telephone calls, emails. I've been a part of organizations that had email change systems, right? Now we have technologies that can support this, that make that easier, that make those digital connections so we can compress the life cycle. We could do more design iterations in a more agile fashion. So that's really what we're showing here in this idealized systems engineering process, focusing just on the first two phases of the design cycle. So that left-hand circle would be representing concept design, right-hand as we move into design engineering. We have some requests coming into the system, right? Either this is new product introduction, or in most cases, you already have a product and just want to make a change to it, right? I've got some feature, something I want to add to that product. So that comes in to this agile process here, where on the left-hand side, we start iterating through our concept design, our systems engineering process. And it starts with the needs analysis, right? Determining needs, goals, objectives. What do I need to put into my product to meet the requirements, the higher level requirements that are coming in. From there, I go into my system requirements decomposition process, where I'll take those high level needs, goals, and objectives. I'll decompose those down, right, into lower level, system, subsystem component requirements. And then I'll start architecting my system, either through documentation and ICDs and interface control documents and requirements documents, or leveraging an MBSE style tool where we can actually create architecture diagrams that can describe what the need is of that system. And we don't just want to stop there. We want to do this concept exploration phase, where COSI calls it design of alternatives. You don't just want to pick the first design that works and just run with it, because there may be a better design, right? So what we want to do is go through the entire design space and look at tens, hundreds, thousands of design iterations and pick the best design, right? The only way we can really do that is if we have an interconnected process here that we can run in a really agile fashion. Otherwise, we would never make a product, right? We'd run out of time by the time we get through all those design iterations. Once I have that baseline design that I'm looking for, I can pass that over to my detailed engineering teams, mechanical, electrical, software, electronics. They're hopefully all working off of this common blueprint, common set of requirements, maybe that architecture that they can leverage to understand what their design space is and all of their interface points to all the other disciplines. Again, in an iterative fashion, so that we can have a feedback loop as changes occur as they do as we go through the design process. And throughout this entire cycle here, we have continuous verification and validation. That means we don't just wait until we have the product on the back end and then simulate it all again, right? Or test it or prototype it. We want to be able to continuously verify and validate our requirements throughout the process. That involves using system level simulation techniques right up front. And then as we get into detailed engineering, more traditional simulation methods and testing methods to make sure that we're continuously verifying and validating that product. The goal is that we find the problems way over here instead of down there when they're really expensive. If I find a problem in concept design, it's fairly inexpensive to fix, right? I'm updating some diagrams, some concept designs, some requirements. If I find it in engineering, I just spent thousands of CAD hours, right, designing something that's not going to work. If I find it in manufacturing, well, so on and so forth, it gets awfully expensive down that right-hand side. So what I've done for today's presentation is I've put together a practical demonstration of this process, taking a slice out of the design process. So we're basically look at day in the life of a requirement, and we'll follow it through the cycle and through the tools to see not only how do we perform the systems engineering process, but how can we leverage Siemens tools to do that as well. So I'm going to start here at the beginning with program planning. And the reason I'm starting with program planning is you saw that kind of needs, goals, objectives, that defining the needs analysis. It usually starts with some kind of program, right? Some project that's defining the change that needs to happen to the product or a new product introduction, et cetera. And we need to be able to organize that in a digital fashion, connecting those pieces of data to all the pieces of data that are going to be coming in from the concept and design phases. So here within Teamcenter, I can browse all my programs. I can see the example that we're going to use here is our E-Rod vehicle. It kind of looks like a go-kart, but we use it for a lot of our demonstrations. It's an actual drivable vehicle. But we've got just a simple program set up where maybe we're adding an ADAS feature. There's a bigger storyline here. We're going to dive into a problem that we're going to find out specifically with the steering knuckle. That was a result of adding a whole bunch of autonomous braking and ADAS features that I don't have time to get into today. But we'll dive into that simple example of the steering knuckle and how we can evaluate that in a systems engineering process. So you can see at the bottom here, as I go through each one of these milestones or events or stage gates that you have on your program plan, we can start collecting information that's in Teamcenter. So I can have deliverables, and depending on the different phase gates, I think the first one I have a system design review and then a preliminary design review. But early on, we'd have things like requirement specifications and system architecture models, and maybe some initial testing that might be performed up there. I may have schedules and project schedules, so we can integrate into Teamcenter Schedule Manager to manage those activities. I can have program risk, so your basic Microsoft project style program management tool. However, it's built into Teamcenter, and it's actually linked and traceable to all the pieces of engineering data, which is the key when we're trying to connect a digital thread. I don't just go to another scheduling tool and say that it was done, right? I'm actually connecting it to the data that's represented in Teamcenter. And then as I go over into the next one, which is PDR, I can show additional deliverables that we're adding. In this case, our engineering bill of materials with the CAD BOM that you can see there. A whole bunch of other tests, because we've done this demonstration a lot. So there's a lot of testing that we've got in there. And you'll see how when we complete these tests and verification requests, they'll automatically get tagged into this program plan. So if I'm a program manager, as people are verifying requirements, as the tests are being complete, as we're automatically getting kind of that pass-fail status, we're going to have automatic visibility from a program level on how we're progressing against our milestones. And then just diving into this project schedule really quick, if you haven't seen Teamcenter Schedule Manager, again, very Microsoft project style schedule management. Some of the benefits here, resource loading with resources that are available in Teamcenter, as well as connecting the different tasks in the schedule with workflow. So now I don't have to have somebody that just goes and updates the schedule 2 weeks after it was actually complete and nobody knows where the schedule's at. I just complete my workflow in Teamcenter as I'm doing my work, and it's automatically updating the schedule for me because it's connected. So just showing some of those areas there. As we move on, we're going to move into system requirements. A lot of our customers have lots of different requirements management tools out there. I'm going to show one configuration and one example. In this case, our Polarian application integrated to Teamcenter. Some of our customers use Polarian for requirements management. Some of our customers are in Teamcenter requirements management. Some use a combination of both. Some use other tools like doors that are out there. Lots of tools that are out there that we integrate to. The key here is going to be looking at that integration and what we can do with that data once it's in Teamcenter. So here I've got a project specifically for this E-Rod inside of Polarian. and I have a live document here where I've taken a traditional document view, but I've broken it down into individual objects. So the key to requirements management is kind of getting away from that document-centric world where you've got really, really long requirements documents that people have to read, and start turning each individual statement, each individual paragraph into an object that has its own life cycle. It can have additional attributes, additional data that we store with it that you couldn't just have in Word. And to be able to link this and have traceability between this piece of data and other pieces of data, like the bill of material or a system model or a test or something I'm executing downstream. So Polarion's a really easy way to transition from that document-centric view to the data-centric view, because it has a very familiar UI that kind of looks like Word Online, but with a click of a button, we now have a table view, and that entire document you can see was just made up of these objects, right? With all of the attributes and workflow and data behind it. I can press a button in Polarion and submit this into Teamcenter and publish it. Here's a dashboard we have specifically in Teamcenter requirements, where I've got that same specification with all of the requirements that have been published into Teamcenter requirements. So now they're going to be consumable by the engineering organization. I can see all of the links that are created, the little link sign in the UI there, that this requirement's connected to parts of my my system architecture, a physical model that we're going to look at in a little bit. It's connected to the bill of material. It's connected to any tests that consume that requirement to verify that requirement. I can open up just that requirement object and get some more information on it, maybe workflows that it's been through for release process, where it's used. Here's all the tests and places where we've consumed that requirement. There's a lot of value in reusability, and with systems engineering, the goal is to get to a point where you have modularity in your products, to say, I might have this feature in my product, like an autonomous feature, for example, if we're talking about a car, right? I might want to use that in 3 or 4 of my models, right? So instead of re-engineering it every time, how can I just grab that piece of the product and everything that goes with it and reuse it, right? And this is a way to do it with this traceability, to say, I want this component in my system architecture and I want to reuse it somewhere else. All the requirements, all the simulation data, all the tests, everything we've ever done on that object is linked now and comes with that object. So this traceability is really important in the overall process. I can visualize that traceability with the relation browser. And then I can also do what we call parameter management within requirements management. So what is a parameter? A parameter is a way to make a requirement measurable through attributes. So for example, the requirement we're going to be working with today says the E-rod steering knuckle weight shall not exceed 3 kilograms, right? Well, that's text, right, in the requirement. Can't really do much with text. So what we can do is we can create a parameter that says, okay, my min is 1, my max is 3, I might have a goal of 1.8, and then a place where it can receive a measured value. You can see we've analyzed this one before, and there was a measured value of 5.9, which you're going to see that problem come up as we go through this, this process. But it's a way to link all the different pieces of information, whether it's to a CAD tool, to a simulation tool, pass it information and receive information digitally, because now we have parameters with units and attributes that we can leverage that piece of data. So looking a little further into the parameter here, you can see it has a life cycle. So I'm working with a lot of customers that I talk with on creating parameter libraries, right? Reusable parameters. A lot of these parameters you use all across your products. You might be testing weight or stress or something. So can we have a library of these parameters that can be consumed and reused? And then we can get a better understanding of, how are we testing against that parameter? Are we doing 3 different tests for 3 different products for the same exact thing, right? So we can measure that that life cycle here. We can see all the historical measurements anytime we've taken a measure against this. So we get a lot of history that's starting to be built up here from a test perspective within the parameter object. And again, it's an object just like any other object in Teamcenter. So it's got traceability. You can see it's linked to the requirement, and then you can see the requirements linked to all this other stuff that we're going to see as we go further through the demonstration. All the tests that are consuming it, we're going to create a test today just to take a look at that. And like I mentioned, revision history. So it's a configuration managed object like everything else is in Teamcenter. So moving on, We're now going to take a look at system architecture. It's going to perform a quick Team Center search here to find the EROD autonomous vehicle model. We're going to show our product system modeling workbench. It's an system model architecture design tool. We integrate with a lot of architecture tools out there. For this demonstration, we'll just show system modeling workbench. One thing that's great about Team Center is that when we integrate something, we give access to the data even if you don't have the application. So if I don't have system modeling workbench, maybe I'm a requirements engineer or a product engineer or a product manager, I don't know anything about system modeling, I can still come into Team Center and interrogate the model, interrogate the diagrams, have a full bill of materials structure. And if you're familiar with COSI, they talk about RFLP, right? That requirements logical, functional logical, physical structure. We create a conceptual bill of material for that we can align to the engineering bill of material. All of that information is available to everyone inside of Team Center without needing access to system modeling workbench in this case, but same way with all the other tools that we integrate with. So I can go ahead and open this directly in system modeling workbench. I could spend probably 3 days just in this tool. So I'm not going to go over all the details of everything that you're seeing. We're going to look at it more as how it's integrated into the overall process here. But basically, we have a systems engineering methodology built into the tool in the middle there, where you can see it walks you from operational analysis to system analysis to logical architecture to physical, etc. What would you use this for? Maybe I'll pause for a second. Is anyone doing system architecture modeling today at all in any of their products? I see it. Okay, blank slate. Excellent. You don't know if I'm wrong. That's good. So anyways, I have customers in aerospace that have hundreds and hundreds of models in SysML, and they create them and they put them in SharePoint. And the first thing I ask them is, why did you create that diagram? Right? So one thing I will say, especially if you're starting to get into system architecture, you'll ask, okay, well, which of these diagrams should we create and why? Well, the ones that are going to bring your business value, right? Don't create a diagram just to create a diagram because some standards that you need to have an activity diagram, right? I see that a lot, and I see a whole bunch of SharePoint sites filled with diagrams that nobody looks at after they were created. So you don't have to follow, the overall process every single time. Maybe you just want a physical architecture. You already have a product, but you want to be able to visualize that product, right? I want to be able to take a look at that physical architecture and say, how do these things connect, right? CAD's great, 3D model's great, and it'll show you what it looks like in 3D, but it's not going to tell you, some underlying things about how it connects, right? You might see the physical connections, but what about electrical or network data connections, right? You may have representations for the wires, maybe you don't, but what the system architecture really allows you to do is put all that information into one place, right? Not just the physical connections and the physical placement of all of these components, but what are their functions? What are they actually doing? Do they have onboard software? Do they need electrical interfaces? Do they need data interfaces? And then what's the chain of functionality that's required to accomplish something, right? In this case, I may have a driver that wants to remotely control something with an app on their cell phone, right? So what has to happen? The driver presses a button on their phone, then it has to go into some kind of maybe Bluetooth controller that's inside the vehicle, and that has to pass information to the autonomous chips that are on the car, and then they have to talk to the steering system, and so on and so forth, right? It's really hard to understand that from just a bill of material. In the system model, you can see, for example, that blue line, that's a chain of functionality. It says, okay, when the user does this, then this has to happen, and this has to happen, and this has to happen. It's really great when you have a change request and you can understand this connectivity to say, oh, we just want to swap out that controller for a different controller, no problem, right? Okay, well, what does that affect? What does that impact, right? You might not know just from your bill of material or the CAD model what that impacts, right? There may be non-physical things, functionality that you need to perform that's not impacted. So the model is really important for that. What I want to highlight today, as you can see here, we've already brought in that requirement from Team Center and linked it to this right steering knuckle component that we're going to be using today. So I can pull an embedded Team Center directly in the system modeling workbench, and I can see that requirement. And then I can just take this parameter as well and drag it out onto the right steering knuckle, and you'll see it creates that link automatically. So there's a drag and drop interface here. So this is great for coverage reports, right? Do all my components have requirements, and vice versa? Are all my requirements, satisfied in the model? But we can create links between all of those requirements, all of the parameters, and the model. And the systems engineers can work with this maybe in the system architecture. Maybe they're doing weight allocation. I can give more weight to this component or less weight to this component, right? So we can make changes in the system architecture, and we can check that back in to Teamcenter, so that way all of the results are available to everyone in Teamcenter. I'm going to click through some of these features a little quickly, just in the effort of time as we go through. But what I will show is, again, the relation browser, right? Here is that one yellow block you saw in the system architecture model. This is that right steering knuckle with the icon there for a physical component. You could see it in this BOM of my physical components coming from the architecture model. But I can link it all over Teamcenter now. You can see here is the right steering knuckle with the CAD data in the bill of material. Here's the requirements, any test cases that I may have, any risks that I may have. So I can start connecting the dots digitally, and you'll see this is very important because we're going to have a change happen with that right steering knuckle, and Teamcenter is going to be able to tell us, oh, hey, all these other things you should probably care about too, because they're linked. I see a key. I can look at overall within the entire architecture model, right? What are all the, like I mentioned before, what are the requirements being consumed? Am I consuming all my requirements in the model? And then is the model satisfying the requirements, right? It's a good check and balance to make sure every requirement is being brought into the design process. Same with the parameters. I can also visually look at interfaces, right? This right steering knuckle, I can have lots of different interfaces, whether they're physical, electrical, etc., right? Hydraulic, all of that can be visualized within our diagram here as well. I see it going the wrong way. All right, let's move into concept exploration. I'm going to really quickly have an aside here on a generative simulation tool that recently came out called SimCenter Studio. What we're able to do is, in a web-based interface, it's based on Jupyter Notebooks, Python Jupyter Notebooks. So it's based on the Python programming language, but we have interfaces to AimSim, Simulink, lots of other simulation tools that we can integrate into it. And basically what we can do is, and I'm just showing an example here, we can have a computational notebook for a generative study. So like I mentioned earlier, you don't just want to take the first design and run with it, right? So I have one architecture that you saw in System Modeling Workbench, but what if I want to look at all of the possible architectures and constrain it based on physics-based models in this case, right? So I have an AimSim model that's saying, hey, I could have 1 electric motor, 2 electric motors, 3 electric motors, right? I can have this many batteries, right? I can start constraining all of my variants, right? What's allowed to be changed, what parameters can be changed, what parameters have to stay constant, right? And connect that to the AimSim model, and then leverage this tool to run a generative simulation that will go through every possible combination within the design space and plot to you all of the results of that design so that you can then choose the best architecture for that design. So here you can see I'm just solving for all the unique architectures. I can start interrogating all the architectures based on the various parameters that I fed it. And when I get to the end and I have all my different designs that were created, I can then post-process those results. Again, it's all Python-based, so things like Plotly, Pandas, NumPy, if you're familiar with Python. And we have a built-in Discover tool where we can select, various attributes, various parameters that we want to compare and plot those. In this case, I want to filter maybe on total weight and max speed, and it'll filter down to just the designs that met those various parameters. And each one of these dots has a whole folder of data behind it, which is the AimSim model, the architecture model, everything that it created for this particular scenario. Now I can say, okay, maybe here's my best design, here's my 3 best designs, and I can pass that forward into Teamcenter now that I've run my generative study. Just a quick aside on that, again, could probably have a 3-day conversation on SimCenter Studio.
Then the show looks like what exactly?
Similar. So it's entirely web-based product and based on some integrations we have with our system simulation tools. All right, so integrations to AimSim and system simulation. But it functions in a similar way, where it's kind of generatively iterating through all your designs, and then giving you the ability to kind of plot the results in various ways to converge on the design that you want.
Well, is there a version of the system here in
I'd say probably, but I'd have to check on that with our academic team. Almost all the Team Center modules I'm showing I know are part of academic packages. I'd have to see if Studio is, but I'd imagine it is as well. I see it.
Is everyone familiar with something? Let's talk about ACE now. Somebody people know ACE is.
Couple? Sure. James' system simulation tool, right? Opposed to kind of your 3D CAE, this is a 2D simulation tool where we've built physics equations into components, and you can create models from those components, and it will solve, basically balance your equations, right? And solve that system that you put together very quickly, because we're using 2D components, we're not meshing anything, right? And for very large systems and very high level analysis, it can be very accurate in providing results, whether it's hydraulics, electrical, mechanical, just using those physics-based equations and solving that system. So, you know, a lot of customers I talk to are using that up front a lot, especially in the concept phase when I don't have a CAD model, right? If I got a CAD model, great, I can mesh it, I can do some simulation on it. If I don't have a CAD model, if it's very early in concept design, AIMSim's really easy to toss some components together, run some basic simulations and say, you know, hey, this design that we want, it's not even possible, right? Let's not waste the money to go build a CAD model, right? When we know, you know, there's no possible combination, you know, the hydraulics or whatever it is just doesn't work. So you get to those answers much quicker with a system simulation tool. We also have a sister tool to that called FlowMaster, which focuses more on large hydraulic systems, but functions very similarly to how AIMSim does. All right, so now we're going to create a test. So I've got that requirement that I'm sitting on here in Team Center, that steering knuckle weight. And because I'm sitting on that requirement, I've just got the create test button here. And this is going to be able to create a test object inside of Team Center. You can see it here. It automatically brought the requirement in, and it will automatically bring in any parameters that are associated with that requirement. So now we've got a container, think of it like a container, that's going to hold all the information for this test that I perform, directly linked to the requirements and the parameters. So I don't have to go, you know, fat finger in my parameters into the system itself. I don't have to go put input parameters into my simulation tool. I don't have to go, you know, write the results down on a piece of paper or a spreadsheet and come back. Everything is going to be digitally connected that you'll see here, as well as the final results on whether we pass or fail. You'll see the parameter that it brought in already had a measurement against it, which is failing. So I get immediate results on, since we've done this multiple times, it's had that measurement in there. And you'll see we'll go remeasure that, retest it, and then figure out what to do about that problem. So I can assign some participants here. We're in Team Center, so everything here is workflow driven and user group and role driven. So I can say who's going to be the engineer that needs to go analyze this. In this case, we're going to pick Ed. I'm going to go ahead and add this to my program plan. Here's where I said it can create that association to that stage gate, in this case, the SDR in the program plan. And by putting it in that table right there, it's going to automatically add it into Team Center program planning for me. And then I could submit it to workflow, which means this is going to go end up in Ed's inbox. And so now we're in the mechanical design portion where we're going to go analyze this. So, you know, Ed kind of looks and says, okay, I've got to analyze this test in my inbox. If you're familiar with Team Center, you know the target of that, the fact that we created the workflow on the test becomes a target. I don't have to go search for it or find it and all the data associated to it. I can just click on it and interrogate it directly from my inbox and kind of see, okay, I've got a weight parameter here that I got to go verify. I can go now open Team Center, and I wanted to show another way to get to that same data, which is embedded Team Center directly within NX. Works the same way in SimCenter 3D. I can go browse again to that test. I see I've got a parameter here. I can go find the top level assembly maybe that I want to load to interrogate the model just by clicking on it and saying open because I'm in NX. It's going to automatically open that model in NX. I'm going to go ahead and just open the piece that I need, which is this right steering knuckle that we're going to go analyze. Now what I can do is go back to that test. I see it. And I can associate this parameter to a feature in the model. If anyone's not familiar with NX, you can create expressions, right? So I can take, for example, I can measure this body and save that measurement as an expression. We have the ability to then link this parameter to that expression. It means every time the designer hits save, It's going to take the actual measurement from NX, and it's going to stick it in the measured value of that parameter automatically throughout the design process. So here we've got that expression here in NX. I've linked it to the parameter, and I immediately, inside of NX, get some feedback that says it's going to fail because it's got a little red X on it. I see it. And when I hit save, it'll take that, since the result is the same, the parameter still fails, it's automatically going to roll up to the requirement and to the overall test that says this test has failed. I can complete that workflow, maybe send it back to the systems engineer or whoever sent that workflow to me as the design engineer, and complete that process. So now I can take a look at my test results. You can see all the times that this thing has failed. We've done it a few times since I recorded this particular demonstration. It's failed a lot. So now we need to figure out how to make this successful. So the way we're going to do that is we're going to use Team-Centered Change Management. So we've got an out-of-the-box CM2 certified change system. In this case, I'm going to create a problem report. You have the ability to associate other information to it, like the parameter and the requirement. I'll point out later on when we get to the impact assessment, a lot of these things would have been automatically picked up by Team-Center, so you didn't have to add it right away. That's part of that traceability that I talked about. But in this case, we'll add a few items to the problem report, pick who the problem report needs to go to, and submit that. I see it. So now I'm going to go to a change dashboard. Here I can see all my changes, CRs, PRs, CNs. It's completely interactive. You can drill down into any of these pie charts and kind of get to the one you need. We just created this one, so it's right at the top, this PR. So I can go ahead and open it. I now have this view of my problem report. I've got my progress, my disposition, where I'm at in the process. I've got all of the problem items that I've added there. I've got a workflow that it's been automatically submitted to. In this case, it's the CM2 workflow that comes out of the box, but if you know Team-Center, these are completely configurable. So the first step I get to is I need to reproduce the problem. So Ed's just going to go in this case, and remeasure it just to make sure it's the right mass or the wrong mass, in this case, the one that's failing. I will note that this process is as you know, as designers, I'm taking a 6 to 12 month process and compressing it into a matter of clicks. So some of these steps may look repetitive, but a month later, somebody goes in and checks it, right? Maybe a few weeks later, somebody goes in and does the next step as you're going through your design process, depending on how long it takes. My record for a CR when I used to work at NASA was 3 years from inception to approval. Hopefully your CRs don't take that long, but they're not as easy as a click. So here, we're just kind of rechecking those results, taking an independent measurement so we don't depend on that expression, making sure that's the same. I say I can reproduce the problem. Again, I'm just an embedded Team-Center here, so I didn't have to leave NX to complete my part. I'm going to say the component requires redesign, hit complete, and this is going to progress that progress, to determine the resolution, and then derive a CR from that PR. So our change system, when you go from your PR, the end of the PR workflow automatically creates a CR, puts the PR in it. Same with the CN. So there's a lot of workflow automation that's happening here that I don't have time to go into everything with you guys, but in this case, I've derived my CR. I can start assigning all my participants, again, configurable, but this is some standard, change specialists, analysts, review board, etc. Depending on what your process is, you would have all your participants assigned. In this case, we're going to staff it all with the same user because that makes it faster. Yeah. So now that we've got our specialist assigned, we've got our analyst assigned, we need to go figure out how to make a better part, right? So obviously that steering knuckle isn't going to work. What are some ways we can go redesign that part? I'm going to send forward a plan to say we're going to go ahead and release that part. I see it. And one thing, I went a little too quick on that one. This impacted analysis folder, this is, let's say, a fairly new feature, maybe 3 or so years old. But it's, I think, one of the most powerful features we have in change management. It's an automated impact assessment. So what this is saying is that your impacted item, in this case, an impacted candidate, is this right steering knuckle. Here are some things that are related that you may not have put as an impacted item into your problem report. So anything in that big tree in the relation browser that you saw that's connected would show up here, and then you could click this little arrow and add it to an impacted items folder, so that is part of the change package. So I think one of the reasons why changes go wrong, I think a lot of times, are the impacts, right? You impact some other system or subsystem or component that you don't catch. You go forward with the change and you change something, and now that other part of the product fails, right? And now you're trying to work your way back and figure out the chain of events that led that one change causing another part of the product to fail. So that automated impact assessment is very powerful. So fast forward, we magically created a new steering knuckle. I'm not going to show you how we did it. But in this case, you could see we used some generative design in NX and SimCenter to create this really uniquely shaped part that hopefully is more lightweight and stronger than the original part. So there's the new component that's been created. Probably has to be 3D printed based on that shape. I don't think we're going to machine that. But what's interesting is we were able to keep all the same mating points, connection points here, right? So that's part of the process in the generative design inside of NX. You can put your constraints in there and say, hey, change everything in the middle to make it stronger and lighter, right? Which is what we did here. So now we need another test, right? We have a new part. We got to go test it. So we're going to create a test. I see it. So we've got our test here. Again, same process. One thing that we're going to do differently here is we've brought in an extra requirement from the impacted items folder. What is this requirement? The material yield stress shall not exceed 602. Well, because we've got a whole new design, I've got to resimulate it, right? Before, I was just checking the weight on the pre-existing part. So I was able to bring in that extra requirement, that extra parameter, and now I have the ability to create multiple tests under this parent verification request, where I might have a simulation request, where I'm just going to analyze only the simulation requirement, and that might go to a simulation engineer. I can add test cases, which are going to be procedural steps that I can make sure get executed during this test. This works the same for physical tests, even though I'm not going to show a physical test example. If I have a prior or existing simulation, I can add the sim files, the simulation models directly to that test so that whoever does the analysis knows there's an existing simulation. And I'm going to add a test run. I might want to run this 5, 6, 7 times, iterate on it if I'm a simulation engineer. I'm just showing that we've got the ability to have multiple runs. We're just going to do one run. And then I'm also going to create a child to recheck that mass. Same process that I'm clicking through here, put the procedure in there from the test case, assign it to Ed, who's going to need to go remeasure that mass. So now I've got a nice nested set of tests that need to be complete for this new steering knuckle. It's made it to workflow, and it's just going to end up in everybody's inbox. They're going to get a pop-up that says, hey, simulation engineer, you got to do the simulation. Design engineer, you've got to go remeasure the mass. So now, as Ed, inside of NX, I can go open that test, interrogate it. I can interactively start walking through the procedure. This is oversimplified. You probably don't need open NX as part of your test procedure, but hey, it's there. So I could say, yep, I opened NX, I opened the verification request, I loaded the component, right? I can walk through my test procedure. The next step is to make the measurement. So this is kind of showing a little bit about how that expression was made in the beginning, but I weigh the mass here, and I can click this button right in the measure tool to save that as an expression for me. So it'll be in that expressions table. I see it here. And then I can add a check to this expression, and that check is where I'm able to select the requirement from Teamcenter. And then you can see it brings in a measured value of 1.71 and change, which is passing. It's between 1 and 3. We get the green pass. I see it. Save that in my model. I can go past kind of the last steps there to review everything. And you can also see on this left-hand side some indication in the BOM structure here that these tests have passed. Right? So you kind of see in a quick view, if you got maybe 100 tests, right, which ones are passing and which ones are failing. So there's some indication there. So now let's look at the simulation request. So here I've opened within SimCenter 3D or NX in this case in my UI, I've opened the simulation file. I've got a simulation that's already been complete, and I want to test it to see if that stress result was the same. So we're able to go to the results manager here inside of SimCenter 3D.
I see it.
And create an expression just like I was creating those expressions for the mass within the NX measurement. And I can see the maximum value here of 418. And because 418 is less than the 600, which was the requirement, you can see that it automatically passed there the second I associated to it. So it's really powerful integration that as we're doing things in the design tool, it's automatically sending that data right up to Team Center, and we're getting real-time feedback in Team Center. This could be someone in another country, right, reviewing this data as it's getting completed and seeing the past results. So now we've got both tests that have passed. So we've got a good design. We've got a new steering knuckle. It's lighter, it's stronger, it passes all of our requirements. We've documented all the results. So here I can complete out this workflow. I can publish all these results out to my specification. So that way on the specification requirement, all of these results are published out there. And once they're published out there, we can go take a look at a nice test results tab that's a part of Team Center requirements, where I can, kind of have some pie charts and some results here of here's all my requirements in this specification, all my test cases, and then all my results. So I can have a nice summary that says everything passed. Yes, this is the end. I am right on time. All right. So the last point I will make, that parameter is extremely important. That parameter object you could see is the object in Team Center that's making all those connections. You saw me use it as an output parameter, which means I was receiving input from NX and SimCenter. You can also create parameters as inputs. So I could take values out of those parameters and drive it as an input parameter into a simulation tool. So that parameters work both ways. But it's that parameter that's the glue between your requirements and your system architecture and your actual verification activities that are happening either via simulation or maybe physical test. You can pull that up and walk through those procedures and enter physical test values as well from a test stand. So I went through that real quick, went through about 5, 6, 7, 8 different Siemens products. But I think the point was that I wanted to show was the digital thread, how seamless it was to move through that ecosystem of products, whether they're Siemens or other integrated products. And we were able to create that digital thread, follow that requirement through its life cycle, automatically see the verification. And the goal here is to get everyone on the same page, find those problems earlier, right? Shift left, make better design decisions, and have that in one integrated place and not in, 10,000 spreadsheets where most of you probably live today, right? It's where I lived back when I was an engineer. So.